Okay, on our second part of 1.4 Experimental Design Day 2, we're going to look at the basic principles of good experimental design. So we want to make sure that we are looking at designing an experiment well, just like we had to make sure with a survey that our answers were clear, that our sampling was random, and all those things that we took into consideration. We have very similar things that we're going to be doing for experimental design as well. The first one is control for lurking variables. This is not the control group, this is the control we have over all the things that are acting on our response variable. This ensures that influences other than the experimental treatments operate equally on all the groups. So we want to make sure that somebody can't come and poke holes in our design and say, oh, it wasn't you're doing the homework that had good grades. It was because you've already taken this class. And I think I've used that example before. 2, another basic principle is random assignment. Again, we want to make sure that the individuals don't have choice in it and that it is randomly assigned. This allows the effects of chance to balance out any one particularly influential individual for making a big difference on the results. So it allows for kind of that evenness over all in our 2 groups or 3 groups or however many groups we have. And then replication, this is where we use enough experimental units to distinguish a difference in the effects of the treatments from just chance variation within our groups itself. So if I only had 3 volunteers from our experiment and I had 2 treatments, so I had one group of 1, one group of 2, that's not enough replication inside my experiment to say that it wasn't individual differences that has caused my result or the lack of results. I need to make sure that I have enough experimental units to say that the results are effects of the treatments, not the individuals in the groups. So a couple ways that we can add to our experimental design is by including a placebo. And this is something that we only have to use when we are working with subjects, so human experimental units. And this is a neutral treatment that has no real effect on the dependent variable. So somebody might be assigned to, a new medicine, an old medicine, and then they might have a control group. Well, obviously we don't want them to know that they're part of the control group. So they would take something that's called a placebo, where they're still taking a pill and they're not sure what group they're in. The placebo effect is when a subject has a positive response to a treatment, but that has no real effect. So they're having that positive response even though they shouldn't have. So that would be like somebody taking a placebo and saying, wow, my headaches really improved when I took that. Well, that's a placebo effect. You haven't actually had an effect happen to you, but you believed that you took something, and so it does get better. And so that's something that we have to consider, but is more of a phenomenon with a placebo than something that we would have to adjust our design for. And in the end, what we are able to do when we do an experimental design that's been set up and executed well is we can say our results are statistically significant. This is when the observed effect is so large that it can't be by chance alone. So this is when we actually look into everything and say, okay, I've done this, this, and this as my treatments, and I've applied them, and I see a difference that is so large that it can't just be by chance. It must be the treatments that I've imposed on my individuals. And so when our results are statistically significant, that's when we start to get that cause and effect idea going on in a well-designed experiment. Our last example here says the physician's health study. It says this study wanted to answer the question if regularly taking aspirin helps protect people against heart attacks. Researchers also wondered if beta carotene would help prevent some forms of cancer. They designed an experiment to test the effects of these 2 drugs. The subjects in this experiment were 21,996 male physicians. There were 2 explanatory variables, aspirin and the beta carotene, each having 2 levels of response, yes or no. 1/4 of the subjects were assigned at random to each of the 4 treatments as described in the table. Okay, so factor 1, they had yes, they got aspirin, no, they got a placebo. And factor 2, the beta carotene, was yes, they got it, or no, they didn't. And so this, they got both, this, they got neither. They were taking 2 placebos. On odd number days, subjects either took the aspirin or the aspirin placebo, depending on which group had been assigned. And on even number days, the subject took the beta carotene or the placebo, depending on which group they had been assigned there. Okay, after several years, 139 of the aspirin group and 239 of the aspirin placebo group had suffered heart attacks. These data are statistically significant enough to say that taking aspirin reduces heart attacks. It does not, however, appear that the beta carotene had any effect on preventing cancer. So this is a big study, and this was something that was done so that they could justify recommending aspirin or the beta carotene. So it says, explain how the 3 basic principles of good experimental design were used in the physician's health study. So how did they address control, random, and replication? So for control, they used like subjects. So they are all male physicians. Placebo for both of the factors, the aspirin and the beta carotene. And then they had a schedule for treatment. So everybody took it on the same day, so they controlled that. As far as random, okay, the subjects were assigned at random to each of the 4 subjects. So assigned at random to one of 4 treatments. And this was going to be replication. How was this included? And so for replication, each treatment group, if we look at we had 21,996. And so if we divide that number by 4, there were about 5,499 subjects in each group. Which is large enough for replication. So this group would be large enough to say that this wasn't any individual differences. This was based on the aspirin or the beta carotene. All right, so if you have any questions, let me know, and have a good one.